Continuing our discussion on logarithmic equations. In this lesson, we're going to look at equations with more than one log. So we're really going to take advantage of those two properties of logs with addition and subtraction. The first two problems here, we have addition. So we need to make use of the log rule that takes the addition and turns it into multiplication inside one log. And so that's exactly what we're going to do. I'll do one problem and I'll let you work on the other one on your own. And I'm actually going to take number 23. Looks a little bit more complicated, so we'll work through that one together. The same steps are true for 22 that we'll do in 23. So looking at 23, log base 3 of x minus 5 plus log base 3 of x plus 3 equals 2. First step is to rewrite it as one log. X minus 5, I've got an addition, so we're going to turn this into multiplication. And now inverse function for log base 3 is going to be 3 to the power. So we'll put all of this equation in an exponent of 3 squared. Make sure that right side gets the base of 3 as well. And then 3 log base 3 properties of inverses say they cancel out. The 3 undoes what the log does. And so we're left with just x minus 5 times x plus 3 equals 3 squared, which is 9. Now I've got a quadratic. I need to multiply this out and subtract both sides by 9 so I get the quadratic equal to 0. So let's distribute x squared plus 3x minus 5x minus 15 equals 9. X squared minus 2x minus 15 equals 9. And now we can subtract 9 and 15, and 9 will give me 24. And now that we have our quadratic equation equal to 0, we can work on the factoring. So since my a is 1, I know I'm going to have x's in the first spots on my binomial factors. I have a subtraction minus 24, so I know I'm going to have a minus and a plus because that's the only way I can multiply and get a negative 24. And then the minus 2x in the middle tells me that the two numbers that multiply to be 24, I need the larger of the numbers to be negative. So we can either do this with the AC method or grouping. Since I am seeing that product pretty clearly, 24 is 6 times 4, and 6 and 4 are 2 away. So I'm going to put minus 6 and plus 4 in. And I can check. So x squared minus 6x plus 4x will give me negative 2x, and then negative 6 times positive 4 is negative 24. It's going to work out. Now each one of these equal to 0. Solve for x, and I get x equals 6 and x equals negative 4. But remember, we have a log equation up here. So if I check these and I put in negative 4, I have a problem. Negative 4 minus 5 is negative 9, and negative 4 plus 3 is negative 1. So we're trying to put a negative number in as an argument for log. That's not allowed. So negative 4 cannot be a solution. Negative numbers are not allowed as arguments for log. Remember, a log function has a domain of 0 to infinity, not including 0. So I can't stick in that negative 4. But I can check the 6. So checking the 6, log base 3 of 1 plus log base 3 of 9, does that equal 2? The exponent on 3 that gives me 1 is 0, because 3 to the 0 will give me 1. The exponent on 3 that gives 9 is 2, because 3 squared is 9. And 0 plus 2 does indeed equal 2, so x equals 6 is my only answer. Excellent. Try this other problem on your own. Again, the steps are very similar to what we just did. You'll go through, you'll end up with a quadratic, you'll try to factor that quadratic, or you could use the quadratic formula or completing the square. Any of the methods for solving quadratic equations are valid here. Most of the problems in standard math textbooks center around factoring because you're already doing complicated mathematics, new mathematics with logs, and you've been practicing factoring the longest. So a lot of times the math textbooks will give you log equations like these, but when you get to the quadratic part, they are factorable. If that rare occasion they're not factorable or you don't see it right away, go ahead and use that quadratic formula. It's totally fine to solve quadratic equations with the quadratic formula. And then let's take a look at one of the last two equations. Notice here we have subtraction. So in our subtraction, log base b r over s, we've got another log property that allows us to turn subtraction into division. And so looking at these problems, I'm going to try 24 and let you try 25 on your own. And we'll shrink our little property and stick it up at the top. So looking at the first problem, log base 2, x plus 2, minus log base 2, x minus 5 equals 3. The minus sign says we need to write this as a quotient, x plus 2 over x minus 5. And so notice all I'm doing is applying that property on one side of the equation. I'm not trying to solve yet. I'm merely trying to get the logs into one log so that I can then start to solve the equation and apply that inverse property. Instead of applying the inverse function to both sides, I'm going to rewrite this as its equivalent exponential equation. The idea is essentially the same though between both types. I have my base 2, my exponent is 3, and it equals whatever's inside the log. So when we write it in that equivalent exponential form, we're writing it in the inverse form. We've got to switch the x and the y. So we end up with 2 to the y equals the input. 2 to the output equals the input. And if we were to apply 2 to both sides, 2 to these as exponents, we'll end up with the same equation. 2 to the third is 8, so we get 8 equals x plus 2 over x minus 5. We've got a rational equation we've got to solve. We can multiply by our greatest common factor, which is just x minus 5. Multiplying by x minus 5 means we cancel that denominator on the right. 8 times x minus 5 equals x plus 2. Multiplying it out, 8x minus 40 equals x plus 2. And then we need to get our x's on the same side and our numbers on the same side. 7x equals 42. So 42 divided by 7 is 6. But I should check, always check, always check. We're going to go all the way back up. Log base 2, 6 plus 2, minus log base 2, 6 minus 5. Does that equal 3? Log base 2 of 8 minus log base 2 of 1. The exponent of 2 that gives me 8 is 3. Because 2 to the third is 8. And the exponent of 2 that gives me 1 is 0, because 2 to the 0 is 1. And 3 minus 0 is indeed equal to 3. Similar steps for that last problem.